a short video about transmission lines. Okay, what is a transmission line? Transmission line is a long conductor with a special design to carry bulk amount of generated power at very high voltage from one station to another as per variation of the voltage level. These lines operate at the voltage level as adopted by the particular region or the nation. Okay, so it transmits the wave of the voltage and the current from one end to another. In the power system study, a line in power system analysis and design treated as a two-port network. So as you can see on Fig 1, so it's a two-port network. We have the sending voltage and the receiving voltage at the end. Okay, the performance of the transmission line is one of the important studies. So basically, in transmission line, determination of the voltage drop, transmission efficiency, line loss, regulation are important things to design. The performance of the transmission line is also affected by the line parameters, like resistance, inductance, and the capacitance. The capacitance of the line is governed by the length. So the resistor and inductance are forming a series impedance here, as you can see in the figure, where the shunt admittance formed by the capacitor or the capacitance of the line. The performance calculation are helpful in system planning. To deal with the performance of the line during normal operating condition, transmission lines are represented by an equivalent model with appropriate circuit parameter on a per-phase basis. Therefore, the three-phase system is reduced to an equivalent single-phase system. The model used to calculate the voltages, currents, and the power flow depend on the length of the line. So we have three models in the transmission line based on the length. The first one is the short lines, up to 80 kilometers. So the model, it would be just the resistor and the inductance of the line would be considered in that model. So the effect of the capacitance on the short transmission line is negligible. Therefore, for studying the performance of the short transmission line, only resistance and inductance of the line is calculated. The second category is the medium length line, so from 80 kilometers to 240 kilometers. The capacitance of the medium transmission line is considered to be lumped at the one or two more points of the lines. The medium transmission line is subdivided into the pi model and T model on the right side. In nominal P model, it is assumed that the half of the capacitance concentrated at each end of the line. In T model, it is assumed that the capacitance of the line is concentrated at the center of the line. And the next category is the longless lines, more than 240 kilometers. For this one, the model is a little bit more complicated, so we consider just a section of the line, and we also assume all the parameters are found to be equally distributed along the entire length of the line.